Hey, so welcome to day 10, and assuming that you're following this dutifully on a day-by-day basis, the way that it's been laid out, then I have to offer my sincere respect for your stick-to-itiveness. No doubt, there's a long road ahead, so I want you to keep up that same level of intensity. Remember, daily baby steps. We're just going to keep pushing forward a little bit every single day until we get this large body of knowledge behind us. Alright, so the job of this video is to give you an overview of the entity framework. We've said much about it already. You've seen it in action now in the previous video. And I want to reiterate a few things about that before we look at some real usage scenarios for the remainder of today's videos. So in day 9, we reviewed the different data access strategies kind of throughout the history of .NET. And you might be wondering, why so many? Well, I believe I already alluded to this before, but it's simply because there's an evolution of thought and understanding that's going on here. As developers use a new technology that just comes out, they begin to learn what its strengths and weaknesses are. And so this prompts the API developers from Microsoft to ask, well, what can we do even better to support the developers in working with data within their applications? So the entity framework is the most advanced data access strategy possibly in all of computing right now. It's simple for simple scenarios and flexible enough to handle more complex scenarios. The entity framework seeks to provide an object-oriented way of working with relational database data. So for years there's been this disconnect between those two worlds. In other words, the thought process, the goals, and even the tools to work with relational database data was subtly, in some cases, or overtly in other cases, very different from the thought process, the goals, and the tools that were available for those who wanted to build object-oriented style applications. So a breed of tools emerged called object relational mappers. And they were created typically by other vendors, but eventually Microsoft got the ORM, the Object Relational Mapper religion, and they built their own, and it has matured over time and evolved into the entity framework. So in day 9, we saw how we used a designer in Visual Studio to import relational database tables into a design surface, and once they were there, we could access those tables as collections and instances of classes that map back ultimately to the underlying database tables. Now, what we looked at was the most basic usage of this technology. There are a ton of features that address many specialized scenarios. For our simple databases and applications, what we did was sufficient, but what I want to do in this video is to give you a peek under the hood to show you what's possible in more advanced scenarios. No, we're not going to demonstrate those advanced features right now. I'm going to reserve a more thorough discussion for another series specifically targeted at the entity framework. However, this should provide a nice high-level discussion about what the entity framework is capable of and what makes it so special. So first of all, let's talk about the heart and the soul of the entity framework, the entity data model, which is represented visually on the designer. And let's open one up right now. From our example in day 9, let's just double click the model1.edmx file. EDMX stands for entity data model, okay? Designer, I guess, by the letter X. And so here we can see a representation of tables from our database that have been converted into C# classes. And so we have a customer that has a series of orders associated with it, okay? Now under the covers, we can see that there's basically an additional file here called the model1.designer.cs. We'll get to that in just a little bit. Let's right-click this model1.emx and select Open With. That opens up the Open With dialog. And I'm going to select the XML text editor. Click OK. It's going to say, are you sure you want to do that? That means I'm going to have to close this visual representation. That's just fine. That's exactly what we want here. All right, so you see XML. We haven't talked about XML up to this point. I'm going to assume that you know a little bit about what it is, and we're not going to get too deep into it in this series. In a future series in the Core 2, we'll talk about XML in more detail. For right now, it looks a lot like HTML. It's a way of defining structures of data in data itself. Okay, it's a semantic way of representing data and an easy exchange between two disparate systems. What does that mean? Don't worry about it. We'll talk about it later. But at any rate, XML is used in this case to represent some things about this entity data model that we just looked at a moment ago. It's just another representation of that entity data model, not visual, XML. The visual derives from this XML and represents it cleanly in our visual designer. Okay, that's why we can double click this again and open it back up in the visual designer. Let's get back to this. Okay, here we go. So under the covers, we can see that there is this additional view of the first file as well as the C# file that's related to it. And this XML file has three main sections that represent, first of all, the storage model, as you can see here, which is also known as the physical model. If we scroll down a little bit, there's this conceptual model area of the document. And then finally, or at least for our purposes now, there is this mapping area here. So the storage model, or the physical model, this represents the actual relational database tables that have been pulled from our SQL Server database in this case. The storage, or rather the physical model, simply represents the database's table structure, as well as the column names, the data types, the relations to other tables, and so on. So when you hear the word model, you should be thinking about a blueprint. In other words, you're not looking at the tables themselves, you're looking at a description of the tables represented in XML. And so as we scroll down, the same is true with this conceptual model, which is XML, that represents the classes that we will consume in our C# code to actually work with the data. Again, it's just a model, and the code will be generated by a Visual Studio tool based on this XML right here. And then finally, as we scroll down one more time to the mapping area, this is a mapping between the columns, tables, and the other information about our database, and it maps it to the properties, the classes, and the collections of our class model. Alright, so why so much effort to separate these out and to understand them in this way? Why not just generate classes directly from the database table definitions and then skip this whole XML model and mapping file stuff? Well, older technologies took that exact approach, but the Entity Framework is attempting to give developers a high degree of flexibility. For one thing, you could start out by defining your class model first, then allow the Entity Framework to generate the database tables and columns based on your class model, so you can go back and forth between the two. Or you can allow your database administrator to break up a single table into multiple tables, which is a common strategy for optimizing a database's performance. But on the C# side and the object-oriented side, you present it as a single class for consumption of the C# developer. Or you could use a single table to contain all types of a given base type. Say, for example, automobile that we worked at earlier in this series of videos. So automobiles, you could have trucks and cars and motorcycles and so on. In the database, we could use one table to store all the various information required by those three separate types, still automobiles. But then you can use on the C# side a rich inheritance model in your class model to take advantage of the features of object-oriented programming. The mapping layer would then guide the Entity Framework in how to translate the creation of a new instance of truck back into the proper set of database columns to store an object of type truck as opposed to type car or motorcycle or what have you. Another common scenario is that you can modify how things are named in the database and how things are named in your C# code. So if a database administrator is following some sort of naming convention that his particular department has established to improve the manageability of the code that they manage, the C# developer can then go in and rename those objects in the object relational mapper, in the object relational model, to be more developer friendly. So the Entity Framework is unique in so much that by separating the models out, it allows a high degree of configurability and mapping between the relational database and the class model. So the entity framework itself is just a simple API, much like other APIs that we've worked with up to this point. In other words, you can work with the entity model and the entity management objects as a series of classes with methods. However, the team provided two additional ways to work with the data. The first is entity SQL, and it kind of looks like a combination of methods and classes with T-SQL, with some notable exceptions, obviously. And then the second way is LINQ to entities, which leverages your existing knowledge of LINQ. And as we've said before, LINQ allows you to work across all kinds of different data, including databases, collections and objects, XML, and more. So LearnVisualStudio.net is going to exclusively teach LINQ to entities for data selection specifically. Some companies or individuals might prefer the entity SQL. I think that would probably be a special case from what I see out there. Most people are using LINQ to entities, not the other ways of working with the entity framework. Not impossible, just not as popular as LINQ to entities. So we're going to focus on that. So when it comes to other operations like inserts, updates, and deletes, it's really a matter of relying on the entity model and the extension methods that are added onto each entity class to perform those kinds of operations. Create me a new instance of this class, and then when we call save changes, it commits that new instance of a class into a new row in the database. Same thing is true with updates. We make a change to a property of a instance of an object that we pulled back from our database. We've made a change to one of the properties, and now we call save changes to save those changes back to the underlying database. Same is true with deletes. We say delete this object, and then we call save changes, which will remove that row of data from our database. Okay. All right, so let's move on. Let's take a look at the code that we wrote to access the entity model. So let's go here to our program.cs class, again from day 9. Now the first line of code here, you can see that we have this real cryptic database 1 entities 1 DE equals new database 1 entities 1. What in the world's going on there, right? Well, first of all, we're creating a new instance of the entity data model. What is that? Well, it's basically this. Let me open this back up here. It's basically this, right? So if we were to click in this white area here and we look at the properties of our database 1 model, the conceptual entity model, it has this property called entity container name, and that's what we are working with. It's the name of our database entities. And so this is often referred to as a context. In fact, if we were to right-click this and select Go to Definition, we would see that it puts us here in this database 1 entities 1 class that derives from object context. So what exactly is an object context? Well, whenever you see the term context in .NET, you should be thinking it's just a fancy word for this is what I'm working with right now, okay? I'm working with this specific entity model, the one called model1.edmx. It has this special name that I gave to it called database 1 entities 1. It's kind of a cryptic name, but admittedly, we just accepted the defaults as we were going through that wizard when we copied, when we created a new entity data model within our application. So you get what you pay for, right? We just got this really cryptic. We could rename this now if we wanted to. We just need to go back through and rename it something a little bit more friendly. But at any rate, you have to create an instance of this class, of this database 1 entities 1, this object context, this entity model, so that we can begin working with the data, or rather the classes that represent the data in the underlying database. So now that we have a context here in this first line of code, we can start referencing the classes that belong to it. So, from our work on day 9, there's no connection to the database. There's no real SQL code here that we execute. All of that is handled by helper classes that are wrapped up in this context, okay? This entity container, this database 1 entities 1 class. When we created a new EDMX file, we went through that process of selecting the connection string and the tables, and so the code is generated to take care of many of those execution details. All we got to do is just create our little LINQ query and then start working with it as if we had the data in hand. Okay? Okay, so the code that we have highlighted right here defines a LINQ query to pull back customers who have orders that are greater than $150. So just so that we are using the correct terminology here, what actually gets pulled back is called an entity set. A set of entities, or rather a collection of individual entity instances. In this case, an entity set of customers. And I believe I already talked about this, but it bears mentioning again that the LINQ to entities interpreter translates this highlighted code into a T-SQL command that'll be executed against our database at the appropriate time. This query is parsed and converted into T-SQL, and other classes and objects are used behind the scenes to return only the data that we need. Also in this example, we're merely selecting instances of a customer class that meet our criteria. Look at the where clause, where there's any orders where the order amount is greater than 150. Now, what we probably should also be doing is returning only those columns that we need. We don't need to know potentially everything there is to know about a customer for our given application. We just need perhaps a couple of columns worth of data. It's generally a best practice, even though I'm not demonstrating it here, it's generally a best practice to project out only those columns, or rather those properties that we need into a new anonymous type in order to conserve memory and network resources. So remember, we talked about projecting to anonymous types in day 9. And again, do as I say, not as I do here. This example was intended to be simple. When you're writing your own applications using LINQ to entities, you're encouraged to be mindful of memory and network usage. So project out only those columns that you need. Use where clauses to only pull back those rows that are applicable to your situation. Okay, so now let's do this. Let's put a breakpoint here in our for each statement. Notice here we've defined our LINQ query, and now we're going to head into our for each, and I'm going to run the application. Because I want to explain another feature of the entity framework. When we run the application, we hit our breakpoint. I want to hover over customers here, and when I do that, notice that in the results view, I don't see anything available to us just yet. It says, expand the results view will enumerate the IEnumerable. Huh? What does that mean? It simply means that it doesn't have any results from the database yet. If you want to see the results from the database, then you want to click on this little refresh icon there within IntelliSense. If we were to look down here within our local scope or our watch window, either one, and we were to expand out customers, we would get the same sort of information. If I were to hit this little tree expand icon here, what would happen is we'd go out to the database and retrieve the results based on this query that we see here. Or if I were to continue to step through this application, right now, we would get then, let's see if we can make this happen. Okay, can't really see it, but what happened is it went off and retrieved the customers for us. Okay, so now we can see that it brings back one customer, Steve Jaworski, from our database and so on. Okay. So why wasn't the data loaded into it after the execution of this line of code? Why did it have to enumerate through each of the individual customer instances in the collection of customers, the entity set of customers? Because to conserve system and network resources, the query is not executed until it is absolutely needed. We can force the issue in IntelliSense by saying that we want to see the results, or we can force the issue by continuing to execute lines of code that will then ultimately trigger the expansion of that query into an actual entity set. However, the data is not loaded until we use it. And that's particularly important as we navigate through relationships. Our LINQ query did not project any order information. We're only pulling back customers in our select statement here. When we navigate later on in our code through the orders collection related to a single customer, LINQ to entities will execute another SQL statement to retrieve those orders. So be mindful of what is happening here. If you're iterating through 1 million customers in your database and each customer has 10 orders, you'll be performing 10,000,001 queries, or I'm sorry, a million and one queries of your database. That's a lot, right? It would definitely degrade performance if we were to execute code like this in that scenario. So you would should consider rewriting your LINQ to pull back just the customer and the order data that you need in a single query, if at all possible. Navigating through established relationships in your entity data model is awfully convenient. However, there's a price to pay for that convenience. And I'm going to have more to say about this in a series devoted to linked entities and a good process that you can use for testing how your application interacts with the database to look for warning signs that you could optimize your code. There's an old programmer saying, make it work right, then make it work fast. Start by getting your application just to work, and then harden your application and make it foolproof. Finally, then worry about optimizing it and optimizing it using an empirical process of analysis and testing and recording the results to get some verifiable data that you've actually made an improvement and you haven't actually taken a step backwards. If you try to optimize too quickly, that's going to lead to some bad decisions as you begin developing your application, or some erroneous conclusions too early on in the development process. Okay, so I think that's a good high-level explanation of the entity framework's strengths. Again, we didn't do the topic justice at all, and there's a lot more to it than what I discussed here. But we have enough background to start establishing a set of working knowledge that we can leverage immediately and then grow our understanding as we move on through this topic. So next up, let's start putting the entity framework through its paces to perform all the typical functions that we would need to perform when we're developing real-life applications. So we'll begin doing that in the next video. We'll see you then.